Investigation of Curves, Section 1, Equations and Properties of Curves. Video 5, Converting from Parametric to Cartesian. In the last videos, we were looking at families of curves expressed in Cartesian, parametric, or polar coordinates. Sometimes it's going to be easier to work in one form for some purposes and for other forms for other purposes. So being able to convert between the different forms turns out to be very, very useful. Let's start by looking at how to convert between parametric and Cartesian. The aim here is to eliminate t to get an equation in just y and x. This doesn't have to be an explicit y equals f of x equation, it could be an implicit equation. One thing to look out for is when there are trig functions in your parametric equations which can be rewritten using trig formulas. But be careful if you're using the computer algebra system for this. Not all computer algebra systems handle trig formulas and trig identities. So for example, in GeoGebra, if you put in a double angle expression such as sine 2x or cos 2x, it's not going to automatically expand that out into the double angle formula. You'll need to do that part yourself. Let's have a look at an example then. State cos 2t in terms of cos t, and hence show that the Cartesian equation for x equals cos t, y equals sine 2t is given by y squared equals 4x squared minus 4x to the 4. Well, for the first part then, I need to write that cos 2t can be expressed as 2 lots of cos t all squared minus 1. Now, we might also write this as cos squared t rather than cos t all squared. When I'm working with the computer algebra system, I like to remind myself that it's not going to be using this cos squared t notation, and that just putting in my brackets, making sure that I know exactly what I'm squaring, means that I'm less likely to fall into any traps. So that's why I've written it that way. Now, hence show that this can be written like this. Well, I'm going to use the fact that I know that cos squared plus sine squared equals 1, and I'm going to consider cos of 2t all squared plus sine of 2t all squared, which I know is equal to 1. Now cos of 2t I've got an expression for here, but I know that cos t is simply x, so I can rewrite this as 2x squared minus 1, that's my cos of 2t, all squared, plus, and sine of 2t, well that's just y, so I've got y squared equals 1. Now expanding this out gives me 4x to the 4th minus 4x squared plus 1 plus y squared equals 1. And then I can just rearrange this to get y squared equals 4x squared minus 4x to the 4 as required. Just looking through that written up neatly. So I started with my cos 2t equals 2 cos t squared minus 1, which you might have written as 2 cos squared t minus 1, but I'm choosing to make it very explicit what's going on in case I'm entering this into my computer algebra system. And then using the fact that cos squared plus sine squared equals 1, I can substitute my x in for my cos t just here, and I can substitute my y in for my sine 2t just here, rearrange, and then I get the desired result. In this video, you've learned how to convert from parametric to Cartesian form.